computer. The time is 9 o'clock, and sort of the clock on the wall agrees as well. So I guess we should get started. Hi everyone. Thanks for coming to this talk. The title of the talk is Modeling versus Reality, and this is something that I've been preoccupied with for quite a while. Sort of the tension, if you like, between reality or the thing that we're sort of embedded in everyone. And the way we sort of look at it or think about that reality. Well, I just think that tension is very fascinating. And in particular, I would like to talk about categorization, which is sort of like a primary tool we use for sense making of the world. And when I talk about sense making, that's sort of the same thing as building a model of how the world or how reality works. So we'll be looking quite a bit at this categorization process. A few words about me, not too many. My name is Einar Høst. I'm a Norwegian software developer. I've been working in the software industry for a little over 20 years now. And I work for the Norwegian Labor and Welfare Administration, which is a fairly large organization by Norwegian standards. It administers a third of the national budget in Norway, which is quite a lot of money. And we use that money to provide like unemployment benefits, sickness benefits, child benefits, pensions, and so on and so forth. And we have a lot of categories. Now, those categories are in place to sort of determine who gets what services under what circumstances. So basically, from the moment you're born as a Norwegian citizen and throughout life until sort of the end, we have a bunch of services in place, and those categories help us sort of use those services as intended, if you like. So in a sense, this is a talk about category theory, but not in the sort of like scary functional programming mathematical sense, but more like theories about how we apply categories to make sense of the world. And according to George Lakoff, we have sort of, everyone has this sort of folk theory of categories. We have our intuitions about how these categories work. So we have an unarticulated set of beliefs about categories, and it rests on three tenets or three parts to it. And the first thing is that things in the world come in these well-defined categories. So the categories sort of neatly partition the world. And if you find an object in the world, you can put it in one of those categories, and then it feels better because we understand the world a little better then. And those categories are characterized by shared properties, so what you call sufficient and necessary properties to belong in the category. And that helps us to determine whether or not an object is a member of our category. And all the sort of objects in that category will have the same properties. And finally, there is one right taxonomy of the categories. So there is sort of like a web or a system that sort of lets us categorize everything nicely. The problem with this folk theory is that these are all wrong. And in a sense, this talk is about how they're wrong and why that matters. And also, hopefully, we'll talk a little bit about why it matters if you want to create software. In addition to this category theory, we'll look at examples of category practice, which is sort of like how we use this category in our sort of day-to-day life. And in particular, we'll look at how the real world has this fascinating tendency to sort of challenge our efforts at trying to impose these categories on the real world. Yes. So now I need a way sort of into this topic, some way to sort of introduce what I wanted to discuss today, and this is what I came up with. I came up with a greeting. So I thought it would be nice to start with a greeting because it's sort of a friendly thing to do, and some of the best greetings in the world start with the word hello, right? So that's a good start. And then fellow, which might be even better because I'm sort of establishing some sort of common ground. We're all in this together. We're all stuck in this world and trying to make sense of it. But then I need to choose a noun. And for the noun, or for the category, if you like, I want to strike sort of like a dissonant chord because this is going too smoothly. So I ended up with hello, fellow apes. And it feels like striking the wrong key on the piano. It's like there's something wrong about that. It would be much, the problem is the category, right? So it would be much easier and less problematic if I'd said something like hello, fellow humans. It's a little bit stilted, and it seems something is a little off. It seems like I'm an imposter or something, trying to sort of fit in, and I'm not really human, but still, it's sort of correct. Like, I could have said something like hello, fellow sentient beings, which is also strange, less problematic, less sort of jarring, and it might have you wondering, okay, is this guy some sort of octopus? But that's okay. You couldn't possibly object to this one. Hello, fellow objects. As we all know, working in software, object is sort of like the base class of everything in the world. Everything's an object. Of course, it's also a very vague greeting, right? Because I'm also greeting all the chairs in the room and so on and so forth. But I chose fellow apes, and the reason was to be a little bit provocative, right? And to sort of start some neurons firing, hopefully, in your brain, and to have us thinking about, okay, what's with these categories? I think apes are probably one of the most problematic alternatives that I could have chosen. And why is that? Why is this so problematic to talk about, sort of classify or categorize us as apes? Why is it so dissonant? It's just it's wrong. Right? Don't we agree that we are apes? I could have said something like hello, fellow grapes, which is also would be wrong, but less problematic in a sense, just absurd. There are a lot of things that I could have said that were wrong, but not interesting wrong in a sense. So we should settle this first, I guess. Do we agree that we are apes? And to answer that, we need to think about, well, what's an ape, right? Or what is the category of apes? What does it mean to belong to that category? And technically, an ape is, as was known as, a clade of animals with a common ancestors. And this sort of approach to classification is known as cladistics, and this is how we currently categorize the species in the world. And technically, there is no doubt, right? So we've identified this common ancestor, right? We know what a human is. We sort of know the human ancestor. We know the common ancestor for all the apes in the world, and there is a relationship where we can't really escape from that. There's nothing more to discuss. So this is now us at the family reunion, and we should be enjoying ourselves. And if we don't, there is sort of a gibbon flanking, so we can't really sort of sneak out without anyone noticing. This is us then, the human ape, and our relatives. And in fact, we are not only are we apes, but we are by far the most common ape on the planet. This ratio here is the chimpanzee to human ratio in the world. There are roughly 300,000 chimpanzees. For each and every one of those, there are 26,000 humans. So there's not even a competition, really. So if you pick an ape at random in the world, chances are you'll pick a human almost every time. So from that perspective, a human is just a hominid in the category of simians, and there shouldn't be a problem. We should sort of just accept that. But there is a problem. And that problem, if there weren't a problem, the introduction would be meaningless and there would be no dissonance, right? So there's a problem, and it has to do, I think, with typicality. We might agree that we are the most common ape, and we are technically apes, but we don't feel like typical apes. And this is a little bit surprising, perhaps a little bit unusual, but it's not entirely unique. We have the same situation for birds. And I once did a talk where I argued that sort of the sparrow is the birdiest bird there is, the most typical birdie, if you like. But the most common bird is not the sparrow, it's the chicken. And the chicken is kind of a pathetic bird, right? It can't even fly properly. But we know why there are so many chickens in the world, right? It's because of us, and we like to eat chicken. And so there are a lot of chickens in the world. So we sort of broke the bird category. Sorry about that nature. But okay, so we have sort of grudgingly accepted that, yes, we are technically apes, but we don't like it. Right? So we've seen the diagrams, we've seen the family photo, and we're uncomfortable. We don't feel like we belong. We don't think of ourselves as apes most of the time. And the reason is that we think of ourselves as human. And of course, we can provide some reasons and some evidence why it's really unreasonable to think of ourselves as apes. Well, first of all, we're not hairy enough. So we have some bodily hair, but most apes that I know of anyway have a lot more hair than most humans I've seen. We are much too upright, as we walk on 2 feet like this, right? Whereas I imagine, I'm not an expert on apes, but I imagine most apes walking on all fours, right? Our arms aren't long enough. Did you see the gibbon? Right? It's way over here. Look at the arms. They're sort of arms aren't long enough. We have weak foot grip. We are poor climbers. We are much, and this has something to do with sort of walking upright, and we're much better adapted to life on the ground than up in the trees. Some of us are afraid of heights. And I imagine that would be sort of very limiting imagine an orangutan being afraid of heights, right? It would be extremely limiting for the orangutan lifestyle to be afraid of heights. But humans can manage very well, at least reasonably well, being afraid of heights. Of course, this is perhaps the most important thing. We are much too intelligent to sort of count ourselves as mere apes. We've even labeled ourselves not too modestly. We're sort of like the wise one, right? Homo sapiens, the intelligent ape, if you like. And I guess there's this. We're not quite fond enough of bananas. Most of us enjoy a banana. If you try to eat 2, you sort of have some doubts going through the second banana, I guess. No one eats 3 in a row. But this is basically my image of a chimpanzee or gorilla, is that they have this bunch of bananas and they chain eat bananas all day long if they can. And this turns out to be wrong. And it's true that bananas sort of distinguish humans and apes. But we eat many more bananas than apes do. And when we talk about bananas, we typically mean this. And technically, this is the fruit of the Cavendish banana. And the Cavendish banana is a domesticated plant. It cannot reproduce, you must clone it, which makes the banana sort of a very interesting category in its own right, in the sense that, in some sense, all bananas are the same banana. Right? And being a domesticated plant means that these other apes can only get to these through us, right? And so we are sort of like the banana dealers of the ape world. And apes will eat bananas, but they do prefer grapes, much like humans do, I guess. So we ended up here. But still, it doesn't matter. We are different, right? So there are some similarities, but there are also sort of important differences that makes the ape label feel like a poor fit. And we have the support of this guy, Ludwig Wittgenstein, who is a very smart ape. And according to Wittgenstein, he says that the meaning of the word is in how it's used. And we don't use the label ape to refer to humans. And if we do, that's an insult. It's a slur, right? It's something that we shouldn't do. And I should apologize for sort of greeting you as apes earlier. It's not something that you should do. So it seems like there is this other notion of ape out there, right? So it's not technical and it's not designed to sort of be precise. It's this casual, informal notion of ape, which is how we use it in everyday life. And in that category, we don't fit so well. But then it becomes sort of like confusing. Well, are we apes or not, right? We know that technically we are apes, but when we don't feel like apes, and it's not our identity, and so on and so forth, it's not really that difficult. Right? What we have are really two distinct contexts and two distinct categories, and the same word denoting both categories in different contexts. So you have sort of if you're work in biology, you need this sort of technical, precise definition of apes, but in everyday life you don't. Still we are confused, and the reason is that we're not really accustomed to thinking about context like this. And even though I said that, well, these are just two different contexts, it might not be immediately obvious that this is correct. And I think we're sort of wired to think that if there are two contexts like this is really the correct one, you know, the expert category, and this is really the wrong one. But we sort of drag our feet, accepting that there is sort of a distinction between the two. But okay, we'll get back to sort of the correctness of categories and so on and so forth. In the meantime, we might ask ourselves, well, just how A are we? Now, if all goes well, and at the end of this talk, if you're a polite audience, you might clap. Which is, to me, like the perfect example of sort of human ape-like behavior, right? There's something very ape-like, like banging your hands together to make noise. And other apes do that as well, but they do for a different reason than we do. They do that, if apes clap their hands, it's to warn of some immediate danger and so something like this. But we as humans are sort of this very socially inclined ape, and so we have invented the technology of applause, which signifies sort of the group's acceptance of the individual. So that, to me, nicely summarizes our sort of dual nature of being both human and ape at the same time. Okay, so that was the introduction. Where does that leave us? Let's see. What's a category? I guess we should... we haven't talked much about theory yet. So now comes the theory, I guess. Well, it's an interesting question what a category is, but what does that question really mean? We might sort of think about the essence of being a category. What is it really? What is the true nature of categories, if you like? That's a very impractical and theoretical perspective, right? We can only speculate about that. It's not clear that there is such a thing as the true nature of categories. But there are other perspectives that we can investigate that are more practical. One perspective is, you might wonder, well, how is a category represented in the human brain? Because we use these categories all the time, so there needs to be something in our brains that sort of encodes these categories. Of course, the short answer is we don't know. But we do have some models, and nice things about models is that you can run experiments to see how well those models hold up. We can test ourselves. We can make predictions, and we can run experiments, and then we see if the results match what the models predict. Now, the so-called classical model of categories is based on essential properties. This is the sort of the model that I talked about in the folk theory that George Lakoff was talking about. And for a very long time, up until the 60s, this was the only model in town. This was the only model that anyone thought about. And it wasn't even thought of as a model, it's just the way things were, right? Then our friend Wittgenstein came along and says it's really quite hard to come up with essential properties for the category of game. There are a bunch of games, but to find sort of the necessary and sufficient properties to just, yes, this thing is a game, pretty hard. And in the 70s, Einar Høst did some experiments that also fit very poorly with the essential properties model. For instance, she did some tests on classifying the color red. And it turns out there are many variations of red, right? Some are clearly very red. And then you have sort of like reddish brown, reddish pink, reddish orange, stuff like that. And at some point, it's going to get hard to be absolutely sure whether you think this is red or not. And people might start saying, well, this guy says yes, but this guy says no. So it seems that these categories these experiments don't fit very well with the predictions of the essential properties model. And so Einar Høst suggested an alternative, which is called the prototype model. And it says that basically you have, for the category, you have a prototype, which is like, in the case of red, something that's extremely red, right? And then you sort of draw a boundary around that. And then as things go sort of gradually less red, at some point you reach sort of the edge cases, that's at the boundary, and then at some point outside that boundary, things are no longer red. And this fits nicer with some of those experiments. Another question we could ask is, well, what are these categories used for? Are they useful, and why are they useful? I said in the beginning that categories or categorization is a tool for sense making, and perhaps the most important tool for sense making. And it's how we organize and structure information about the world. And that's pretty important because we are in this world and we need to sort of work with it. And we go through this process as well. This is like that, this is identical to that, and so I can treat it the same. This is roughly the same as that. Maybe I can still treat it the same. This is definitely different, so I need to do something different here. You go through this constant sort of loop of comparison and sorting and classification and distinguishing. And this is very important because it enables language. Right? So if everything were these individual ungrouped objects, then they would need unique names. We'd have to sort of put a quid on everything in the world, and language would be very useless. Statements would be very weak because we would only talk about one thing at a time. And it also then enables economy of thought because we can sort of think about whole groups of things at the same time. And it allows for economy of communication as well. It enables induction, so we can learn about things. So from my experiences with specific members of a category, I can make hypotheses about the other members as well. So basically, if my glass was like that and there was a cat here and the cat was pushing this glass off the table, I could learn from that situation, and the next time I'm in the same situation with a glass and a cat, I'll be watching my glass of water, right? So I can learn that cats do pranks, if you like. So it enables learning, and it's also very useful because it means you don't need direct experience with every object in the world. And sort of traveling from Norway to Denmark, that's very useful because I can use the restrooms in Denmark even though I don't have experience with them from before. It works the same way, so I can rely on my experience from before. So it enables navigation, choice, planning, meaningful action. It enables us to be effective agents in the world. So, super useful. So that's a bit of category theory. Let's look at categorization in practice. And sort of the short message here is categorization in practice is hilarious. This is the reason why I think this is so fascinating. Because I think it's very, very amusing. And it is amusing basically because reality kicks back, right? I'm going to start by talking about what you could call everyday casual modeling. And then we'll sort of talk about what happens when we need to move from that to something more specific, something more technical. For instance, when you want to create a software system. And this everyday categorization is coarse, it's imprecise, and it's partial, but it's mostly adequate. And it's also incredibly useful. And some of that, it's important to note, and it's not obvious perhaps, some of that usefulness comes from being coarse and imprecise and partial. Because it enables us to use fewer categories, and that's very, very useful. And you use them to achieve goals. Now there is a quote by Rebecca Wurzbrock that I really like. And of course, you should never do this. I've sort of lifted a quote out of its context, so you have no idea what the context is. And I don't either, really, to be honest. But knowing Rebecca a little bit, it's probably about modeling. And what she says is that the longer you investigate something, the less coherent it becomes. And it fits very nicely to this topic of categories. So one of the fundamental sort of problems or challenges we have with categories is determining category membership. Does this thing belong in the category or not? This is known as sort of membership evaluation. And when you think about those two different models that we talked about, this essential properties versus the prototype, you have sort of the distinction between a Boolean thing. So if you have the essential properties model, either you have the essential properties and you are a member of the category, or you don't. So it's like a Boolean, it's true or false. Whereas in the prototype model, it allows for, this is like 100% member of the category, this is more like 75, and then it's 50, and then you don't really know where you should put the boundary. Should I put it at 50, 60, 70%? but it allows for a rating, right? So I said I would look at some practice. So let's look at some examples. And sometimes it's very easy to determine whether or not something is a member of the category. For instance, like this. So is this thing a member of the horse category? I'm going to use the sort of the prototype model here. So I'm going to say that the hoarseness in this case is very high. Now you could imagine me being like an AI saying I'm very confident now. I have a confidence rate or that's close to 1 or something like that. So yes, quite confident that this is a horse. What about this one? Well, I'm going to say quite low. Probably outside the boundary of the horse category. But it's not sort of all bad, right? It's still a mammal. It's a little bit small. It's on the small side. It's smaller than most horses, I think. It has 4 legs. Yeah, but it's not a horse, I guess. But this one, it's a horse. Well, hoarseness is probably even lower in this case, but it's still it's made of organic material. It has 4 legs, so it has some of the shared properties, if you like, but not all of them. And it's too different to sort of count it as a horse. But this, well, I think the hoarseness is practically 0 here. Let's hope that's not horse. It's probably chicken. Right? But sometimes it can be a little bit harder. What about this one? It's the horse. I'm going to rate it at medium plus. But after I've sort of used this example for a while, I started wondering, well, why don't I rate this higher? Why is this sort of the hoarseness high in this case? Because to me, sort of, it doesn't really matter if this is a horse or not. It's pretty horse-like, right? And what I found was the only reason I don't say that this is a horse is that hoarseness isn't an independent category. Right? My rating of the hoarseness depends on the existence or absence of other categories. And the only thing that destroys sort of lowers my rating for this case that we looked at, well, let's see if this works. It's the donkeyness. So it's the donkeyness that sabotages the hoarseness of the donkey. The only reason that the donkey isn't a horse is that there are donkeys in the world, right? There is a category of donkeys, and I'm aware of that category, and so I have to use it. And then that means I can't accept this as a horse anymore. And this is actually a property of categories that neither the essential properties model or the prototype model of Einar Høst accounts for. Right? In both those cases, it's seen as classification of or membership evaluation for a category is something that happens independently. But apparently, other categories can influence our judgment, and it does. And there are some models. They're sort of more convoluted or complex, if you like. So we're not going to talk about those, but it's worth noting. So let's try another example. I don't know if you can see this. You can't really do a talk, I think, about categorization without talking about tomatoes. And the reason that it's so hard, right, to classify a tomato correctly, so is it a fruit or is it a vegetable? And we sort of have to make this reverse process because we know that there's something mysterious about the tomato. It's in the wrong category, right? And we remember that. So it's, oh, well, a tomato should be a vegetable, but it's the wrong one, so it's probably a fruit then. So the right answer is the fruit, right? And I think we think entirely wrongly about tomatoes. And if you ask me, I'm going to say, well, it's really more like it's 70% vegetable and a little bit fruit. This is my everyday casual categorization. And I don't think I agree that I need to choose. the reason that I feel I need to choose is that I have this belief that sort of categories are disjunct, so they can't be in several categories at once. And probably it has something to do with there's this one taxonomy that organizes all the categories in the world, and everything fits neatly into one. And this is probably the folk theory of categorization again. But I don't agree. I think it's mostly a vegetable to me. I would never put it in a fruit salad. But the most important thing, I guess, is that outside a given context, I can't really know. So it's like a Schrodinger's tomato, right? If I'm not providing context for my evaluation of categories, I don't know what I should do. And there's this friend Rameau said something very nicely about tomatoes. He said that in the culinary context, tomato is a vegetable. In the botanic boundary context, it's a fruit. And if you're doing theater, tomatoes are feedback. And I thought about that for a while, and I realized that the last one probably applies to conference talks as well. And that means at the end of this talk, now you have a choice. You can either clap your hands, or you can throw a tomato. And then you can sort of think for yourself, if you think, what do you think is the most ape-like behavior of those two things? The important thing here is that categories are contextual. They can be fuzzy. This sort of boundary isn't necessarily clear. There are degrees of membership. And to illustrate that, let's talk about something else. This here is chess. And there are many, many interesting things you can say about chess. One thing you could ask people is, do you think that chess is a sport? And people will get into very heated debates about this. Right? And then you can probably look it up online, and you definitely shouldn't. It's going to waste your time. Now, if you ask people whether or not chess is a sport, they will say, on average, people will agree that, well, chess belongs to the category, this is a very specialized category, of sports that are also games. I'm not sure if I could list like a lot of other examples belonging to these categories, but if you ask people if chess belongs to this category, they will say yes. And they will also say that, well, no, chess is not a sport. So obviously, a sort of classical logic is out the window, right? Because presumably, this would be a subset of all sports. But it doesn't seem like it works that way. Maybe, I think people feel like this is an extension, right? This is pushing the boundary of sports, if you like. I want to talk a little bit about the relations between categories. We touched on this with the donkeys and the horses. The categories are not independent. We like to sort of structure our categories into taxonomies. And in particular, we like to organize things in hierarchies because it makes it easier to reason about the world. And then we sort of create a system of generalizations and specializations. And this here is sort of how we currently classify all the living things. So we have our species, our genus, our family, our order, a class, a phylum, and a kingdom. But it's important when you see a hierarchy like this to realize that this is human-made. Right? So we shouldn't take this too seriously. This is just a model. Right? So we've had plenty of models for organizing living things before this. We will probably have another one at some later point, if and when sort of scientists agree that it would be better if we split this or we move this or whatever. So this is just a model. And in fact, as I was sort of researching this talk, I was Googling things about classifications of animals. And I got this helpful list of other questions that people ask. Right? What are the 7 classifications of animals? What are the 5 classifications of animals? What are the 10 classifications of animals? What are the 6 major classifications of animals? What are the 11 groups of animals? And what are the 7 characteristics of animals? So it's important to not take this too seriously. This is just a way that we want to organize the world, is us imposing a model onto reality. And reality isn't aware of this. Reality doesn't care. And we see that whenever reality trips us up. And to be honest, really, there are not even such a thing as a species, right? I was reading this book by a philosopher called John Gray, and he said this sort of jumped out at me. There are no species. Species is just another one of our abstractions. What a species is really just a group of living organisms that are sort of like similar individuals that are capable of interbreeding. But all we really have are these individuals carrying DNA sort of around and having DNA that happens to be compatible enough that can produce offspring. That's what a species is. So again, we shouldn't take, I mean, in a sense, abstractions are super important, categories are super important, but it's also important to remember that they're sort of, we shouldn't take them too seriously. Next thing I want to talk about is a phenomenon called basic level categories that sort of appears in hierarchies. But when you have a hierarchy of categories, one of those is sort of special. And we can identify it as a basic level category. And it's special in the sense that we prefer it. And when I say prefer, that's something we can test for. And it's not something we're very aware of, but it's something we can test for. And it means that in the hierarchy, we will typically be better at classifying at that level. And a typical level, I like to use the example dog. Right? So typically, if you see an animal running towards you, you will quickly say, oh, that's a dog. And you will say that much quicker than you will say either that's an animal or that's a German Shepherd. And that's the basic level. So we're quicker at identifying at that level. And we do that, the way we sort of come up with these basic levels is through a process of difference in information, because we can only fit so many categories in our brains, right? And our brains are super pragmatic in the sense that we want to sort of maximize the usefulness of our categories. So we want categories that provide a lot of information, but are also very different from each other, right? The category of dog provides a lot of information. If I have the category of poodle, that provides even more information, but then I sort of have to explode the dog category and have all the other dogs as well, right? And our brain doesn't like that. So it's sort of it's economizing so that I just use this dog category, and that sort of gets me through most of the scenarios when I encounter German Shepherds or poodles. Whereas it's very useful to distinguish between a dog and a cat. Now I say this is sort of the brain chooses or whatever, but this is an automatic process. It's not something you can control very easily. It's a sort of built-in feature of our brains. And it's not entirely sort of static or universal. It's built on utility and experience. So it adapts to what's useful to us. It's really quite remarkable. It's based on experience, and it depends on our expertise. That means that it's also culture specific. I took a picture of this as I was walking through a park one day. This is a very beautiful tree, but I can't tell you what kind of tree it is because I don't know. So when I see something like this, and I say, whoa, that's a beautiful tree. But if I made my living in the forest, maybe I'd know what it was, and maybe I'd even push down my basic level preference so that the immediate thought would not be tree, but whatever tree this is. Right? So it sort of adapts to what's most useful to me. But sort of like Rebecca Versbrock was hinting at, it's always sort of less coherent and more complicated when you talk about categorization. So this is only approximately correct. I'd like to run a little experiment to see if we can sort of uncover some of that complexity. And for that, I need your participation. What I'd like to do is I want to show you a couple of pictures, and I'd like you to categorize it as quickly as you can. And I know that you can do this super quickly. I mean like milliseconds, right? Our brains have evolved over thousands of years to do this super fast. So it's amazing how good we are at this. It's pattern recognition and classification. Really, really quite amazing. So I want you to do sort of be as quick as you can. And I'm going to run a little test before the experiment just to see that we sort of get the participation going and so on and so forth. So as soon as you know what you're looking at, shout it out, and shout it out loudly so I can hear it. Okay, so it's a countdown. Horse. Perfect. So you agree that the hoarseness is very high in this case, right? Yes. Good. This is the same horse that we saw before. So let's try to run the experiment. I'm going to show you 2 more pictures, and I want to do the exact same thing. This is the first picture. So we have another countdown. I heard 2 things, and one of those was faster than the other one. Second picture. It's very interesting, isn't it? So what happened here? We're talking about hierarchies. Like this is a very simple hierarchy. And I was talking about the basic level preference. And for me, at least, basic level preference is bird. And I think we both agree, or all of us agree, that robins or penguins are all birds. But still, we ended up classifying overwhelmingly the robin as a bird and the penguin as a penguin. So apparently there's something more going on. And in a sense, you can think about it like robin is a bird that happens to be a robin. It's sort of like a detail that it's a robin, right? And to be honest, I would guess that some of you people, including me really, when you see a picture like this, oh, I'm not necessarily, I have to think a bit to come up with the fact that this is a robin, right? So robin is a bird that happens to be a robin, penguin is a penguin that happens to be a bird, which is a sort of inverted thing. And that's a convoluted way of saying that robins are typical birds, whereas penguins are atypical birds. And that means that when we classify penguins as birds, we feel we lose something vital about the penguin, right? And this isn't something we do consciously. We just saw that it happens automatically, right? Very quickly. And this actually has, so in a sense, you can think of a penguin now as a edge case in the bird category, right? And edge cases are special. And this has all kinds of interesting effects. For instance, if there's a disease that affects robins, we tend to sort of generalize and say that that disease is probably a problem for all birds, right? All birds can get that disease. Whereas if there is a disease that affects penguins, we're much more likely to think that's probably a penguin-specific thing. Right? Robins are probably safe. So typical cases are categorized at the basic level, whereas these atypical cases, or edge cases if you like, are categorized at the subordinate level. So because our brains feel that we lose something vital, we need to sort of go deeper. And there are more problems. We want to sort of create these nice taxonomies. One of the nice things about this classical property-based view is that it supports logical inference. Right? So if we have these clear boundaries and sort of Boolean category membership, we can apply classical logic to our categories, and that's very, very powerful. So that would be very nice if we could do that. Unfortunately, categories don't seem to work that way. So if you have 3 categories A, B, and C, the notion of transitivity means that if every member of A is also a member of B, and every member of B is also a member of C, then it holds that all A's are C as well. Non-transitivity means that this doesn't hold. So we have more examples. And here's an example of non-transitivity in categories. If you ask people if chairs are furniture, they will overwhelmingly say yes. Furniture rate is very high or something like that. If you ask people if car seats are chairs, Well, again, majority is going to say yes. Some might say no, but most people are going to say yes. Now, if you ask people if car seats are furniture, they're going to say no. So we have car seats or chairs, chairs are furniture, car seats are not furniture. So transitivity is out the window, and the reason, of course, is again that our categories are not crisp and clear. We cannot apply this sort of reasoning. They are fuzzy. There are degrees of membership, and we have these problematic edge cases, which is what happens sort of when your membership weakens and your rating drops. And then you have these objects where it's not so clear what the membership status really should be. And that means that can lead to discussions sometimes. People argue whether or not something belongs to a category, right? Which is really arguing at the same time, what should the category be? I wanted an illustration for negotiation, but all I could find were these sort of business people shaking hands, which is not it's not a good representation of what negotiation in practice looks like. It's more like this. And there's this classic discussion in software, right? People have strong opinions about this. There might be some people in the room who have strong opinions about this. I don't have a strong opinion about this. I think the real question is whether or not we want HTML to be a programming language, right? So it has to do something about what should this category be. And that's a choice. We can choose to say, yes, we want to include it, and there will be some consequences of that. We can say, no, we want to exclude it, and there will be some other consequences of that. But the problem is, in this discussion, we tend to confuse what's descriptive with what is normative. Right? So we think that we're making an objective statement, like HTML is not a programming language. But what you're really saying is, I don't want HTML to be a programming language, right? So you want to influence the definition of the category. Of course, the problem is never with the object itself. The object isn't really aware of the category. So the problem is always the category. The object just is what it is. HTML is just HTML. It doesn't change based on whether or not we put it in the category of programming languages. And of course, the platypus agrees with us. Platypus is a very strange animal, we say, because it's a mammal that lays eggs, and mammals shouldn't lay eggs, and it's sort of very problematic. Again, this is not a problem for the platypus. For the platypus, there is nothing more natural in the world than being a platypus, right? So it's just us having problems with our categories, and that's not really something we can blame on this fine animal. Now, sometimes these category discussions, perhaps often, there are proxy discussions for something else. So the discussion of whether or not HTML is a programming language also determines who is a programmer. And there might be sort of consequences of doing that. There might be things like how much you're paid, how much status you have, stuff like that. And so we shouldn't be too naive about what's going on in these discussions, because the ability to define a category also lets you exercise power over the domain. And I think that's one of the reasons also why these debates can get quite heated. So a question like, is X a member of Y, sounds very objective, but often it's not. It has consequences. And when we're confronted with a question like that, we shouldn't sort of rush towards saying, oh yes, we're going to answer yes or no in absolute terms. We're going to sort of have a discussion, well, what are the implications? What are sort of the pros and cons of including or excluding X from Y? And they're going to be trade-offs. When you start talking like this, it sounds like we're doing modeling, and that's because we are, right? We're creating a model of how we want to think about the world. And when I talk about modeling in terms of software, or when we sort of want to be more precise, I like to think of modeling as a technification of categories. And I'm not sure if technification is a word, but I just invented it, so now it is. But it's a process of eliminating ambiguity. And we're used to thinking that ambiguity is bad, but for sort of everyday casual modeling, ambiguity is sort of an enabler. It's what enables us to make do with a relatively small set of categories that are immensely useful. But when we want to sort of technify our categories and be very precise, we need to do something about these edge cases. And they are not a problem in everyday life, but they are when we sort of want to create software, say. Now, this technification of categories can have some surprising consequences. And one of those we've seen with the tomatoes, right? Also, it turns out that fruits are really nuts. Oh, nuts are really fruits, rather. Almonds are not nuts. It seems like we're wrong about everything, right? All our categories are wrong. All our intuitions are wrong. But of course, we're not wrong. This is just the same thing that we went through before with the apes, right? We were sort of forgetting that there are two different contexts. What's missing is this context, and we have this tension between everyday and technical categories. We're sort of confusing them and thinking, perhaps, that one of them must be correct and the other must be wrong. We use these technical categories for precision, but they're not the same as the everyday categories. They just share the same name. That's why we get confused. Now, this precision comes at cost. We've seen some of that before. I'd like to mention a few examples from categories where I work at the Norwegian Labour and Welfare Administration. And a lot of these categories are actually sort of written down in Norwegian law, right? Because that's what determines who gets what under what circumstances. And I like to call this variations on a theme. And the theme is unmarried people who live together. And this sounds like an unproblematic, unambiguous category. Here are some variation taken from Norwegian law. Two people of 18 years of age who are not married, registered partners, or living with anyone else. Two people who usually live together, even if they are temporarily separated. Two people living in the same house, even if they live in separate parts of the house, unless they each live in separate units in a house with 4 or more independent, clearly separated units. Two people who have previously been married, who are living together in a marriage-like relationship, who could legally get married or enter a partnership, who have or are expecting children together, who have or have had children together, who live in a joint residence, who live in a common household, who have to live together for at least 12 months, who have lived together for 12 of the last 18 months, who intend to keep living together. Now, so as I mentioned, precision comes at a cost. And in this case, the cost is in a sort of explosion of almost identical categories. So very similar categories. And sort of your gut reaction might be that, well, Norwegian law needs to be simplified. There can be no reason why we need so many almost identical categories. And you might be right. But at the same time, the law is the way that it is for a reason. And we want this to be as fair as possible. And then we want precision, right? It might be that changing some of these definitions, changing some of these laws, really, might have profound effects on who gets what, and also how much we spend. And we want it to be fair. So the important thing here is really that we must choose. Right? Choices are not right or wrong, but they must be made. And those choices have consequences. We make decisions when we create categories. How many categories should we use? Is it worth the complexity of all these different categories, or we want one simpler one? And when we make these decisions, they are sort of made on the basis of an implicit model of the world. And not just the world today, but also how we think the world is going to evolve. We have implicit opinions about what matters and what doesn't matter, and also what's going to matter in the future. So we have these tacit assumptions that underlie the decisions that we make. And the problem with assumptions is that they are, in a sense, bets against the future. Right? We assume that what we hold to be true today is also going to hold tomorrow. And I think the biggest unsolved problem in modeling and in software development in general is the passing of time. Right? And it's going to be hard to solve that one, as we're going to have to live with it instead, I guess. But again, one of the problems with time is that these assumptions and decisions that we make every week and put into production, they accumulate over time. And we're sort of weighed down by the accumulated weight of our assumptions about the world. This is from a Norwegian TV show called Mesternes Mester, where we have these ex-athletes that compete against each other. This is called gravity, I think. And each athlete walks these rounds. You can think of them as sprints. And for each round they pick up a big bag of sand, and then sort of the goal of the exercise is to keep walking for as long as you can. Sometimes software development feels a little bit like that. And we often call it technical debt. But I think that's sort of a misnomer, because what we're really accumulating are these assumptions. And in a sense, we're dealing with an inevitable byproduct of change and inertia. The inertia is sort of in the things that we have already made, and then we have the world changing around us. So it's worth considering when we want to change the software, or when some change happens that we need to respond to, what is the impact of that change? Now, you might be asked questions like, well, how long is it going to take to implement this feature? And then we need to ask questions, well, how is this feature going to change our mental model? How many assumptions have we made that are now invalidated because of this new feature? If we're lucky, there are not a lot of assumptions that are invalidated, maybe none, but maybe there are some. And then we need to think about that. How many decisions have we made that must be done and remade in a different way? And in particular, how much structure have we built on top of these invalidated assumptions? How much structure now relies on obsolete decisions? And it's very often to think about, it's common to think about technical structure, like the code running in production. That's a problem, right? Because that's sort of a manifestation of the assumptions that we made, or our model of the world. But it's also things like organizational structure, or even economic structure. We sort of organize ourselves in a particular way because we think that's efficient in the world that we live in. And if the world changes in a profound way, well, maybe that's no longer the best way to be organized. And when we sort of talk about how economy is, or money is structured, that also means power structure. And it's made worse by the fact that these are not independent. They're sort of mutually reinforcing structures. And that can lead to entrenchment and ossification, which I think is a fancy word for turning into rock, being hard to change. Now, I often like to care an alternative way to sort of talk about software development is through sort of comparing with the game of Tetris. So we have some degrees of freedom starting out, but when we make some assumption that we sort of limits our degrees of freedom going forward, maybe we have some indecision that's going to, but we have sort of to act anyway, and time passes. We make some generalization, which is another way to sort of bet against the future. We have some ambiguity that sort of gets manifested in our code. We have some misunderstandings, a conflict, and then it's game over. So that's a different way, a different perspective of software development. And in a sense, the task is not to win the game, because you can never win at Tetris. The task is to play well. Play for as long as you can. Keep walking in this gravity exercise. And I think modeling is our best bet for accomplishing that. And then modeling thought of as the deliberate design of these technical categories, where we are not sort of blind to the assumptions that we make when we handle our edge cases and so on and so forth. A problem, of course, is that modeling is really difficult. It's not only difficult, it's uncomfortable, because it's, in a sense, it's meta-programming. You're sort of changing the categories in your brain at the same time as you're using those categories. This can lead to discomfort, in particular if you're not used to it. And you might meet some resistance even if you sort of want to invite people to participate in modeling. And you might meet questions like, why are you making it so complicated? Which is really what you would say from the perspective of sort of everyday casual modeling. It doesn't need to handle ambiguity and the technification of categories, right? So people might ask, why are you making it so complicated? And the reason, of course, the real answer is to avoid making it unnecessarily complicated over time. It's to embrace the actual complexity that's there and not to sort of sweep it under the rug. I think modeling is teachable. One thing you can do is learn about categories. There are some excellent books to read. One of those is The Big Book of Concepts. by Murphy. There's also Women, Fire, and Dangerous Things by George Lakoff. It talks a lot about the research that Eleanor Roche did. There's Sorting Things Out by Boker and Starr. And finally, I just want to leave you with this, that apparently in California, bees are now officially a type of fish. And I hope that by the end of this talk, you will not be thinking, well, what are they smoking in California? And maybe even thinking you know the answer to that, but rather to think, what is the context where it makes sense to classify bees as fish? Thank you.